Alright, so here we go. Solving rational functions, part 3. Just want to use cross multiplication here. So cross multiplied. And if you're wondering why that's okay to cross multiply, well, take some fraction that you think is equal to another fraction. I think that 2/3 is equal to 2/3 is equal to 16 over 24. Is that right? Sure. Yes, of course. So why is that true? How can I prove this true? We'll just go across, right? 3 times 16 is 48, so 48. And then go backwards. 2 times 24, 24 times 2 is 48, and 48 equals 48. And you think, oh, that was very clever. It wasn't clever at all. Find your own example. Take two fractions that you're sure are equal to one another and cross multiply and see if it doesn't come out true. And when it does, you'll have some verification of why you're allowed to do that. So this is what I'm going to do. I'm going to keep in mind one thing that it seems to, it's a very common mistake for people, is that this x minus 1 is the factor. There's not a factor of x and a factor of -1 in here. The factor is x minus 1. And here the factor is x squared minus x. And here the factor is 2, and here the factor is 1. And you're asking me, why does that matter? Well, you'll see in just one second, I think. So I'm going to use this cross multiplying technique, and I'm going to take this 1 right here, take this 1 right here, and multiply this 1 times this x squared minus x right here. And I'm going to take this is equal to, and then I'm going to go the other way, right? Go the other way, this way. And I'm going to take this 2, this 2, this 2 right here is this 2 right here, this 2, times, and we're going to multiply that times 2x minus 1. I'm sorry, x minus 1, so x minus 1, right? We know when we multiply this whole mess and nothing happens, does it? We don't get anything, but right? So we just get our x squared minus x back, don't we? X minus x here, and this equal sign is this equal sign, but 2 times this, remember we have to distribute completely, so we're going to distribute right into there. So 2 times x is 2x, and 2 times -1 is -2, isn't it? All right. So this is the thing I keep talking to everybody about, and when you catch on to this, it's going to make your life easy. So I'm going to stop for a second. I'm going to look at what I have. Do I have a line anymore? No, this is not a line because I go to a variable and I say, what's its highest exponential value? And the highest exponential value is 2. So when I see this variable raised to the second power and it's the highest one, I realize, oh, you know what? I remember that if this is a quadratic, and quadratics are solved by taking ax squared plus bx plus c and setting them equal to 0. Right? So I recognize this, and that's how I figured out what I was going to do now. So some recognition. This is huge in calculus. If you're going to be great at calculus, you have to be looking for this kind of stuff all the time. So what I'm going to do is I'm going to start moving things over, and I'm going to add -2x to this side, and I'm also going to add +2. And if you see what that would do, it would get rid of all this crap here, wouldn't it? And I would still have x squared. Remember, if I add it to this, I'm going to add it to this side, so -2x is over here, which is -2x. I'm going to have to add a +2 here, right? I add it to this side, I add the same thing to this side, so +2 is equal to 0, isn't it? All right? All right, let me have 1 second here. I stopped for a second because I was like, this is not working out good. So, okay, I wish you were here with me because then you would be able to say, hey, Charlie, look, -x plus -2x is -3x's. So I was starting to do my factoring. I was like, this is not cool. So, look, isn't this form right here, this form right here? And that's what we're going for. And now we're going to factor this. And we factor it to x, what is it? X minus 2 times x minus 1 equals 0. We're going to use this thing called the zero product property, aren't we? And using the zero product property, we're just going to do a little bit more work here. Why does that always happen? It drives me nuts. So we're going to solve. When is x minus 2 equal to 0? When x is equal to 2, so that's one solution. And when is x minus 1 equal to 0? Well, of course, when x is equal to 1. So there are our two solutions. All right, you guys, thanks for hanging in there with me. Good work. Remember, always looking for patterns, right? Always, always, always looking for patterns.